This is a presentation about graphs at GCSE. It's about plotting graphs and calculating the gradient. There's also some chemistry because it was taken from an AQA past paper question. You can download the paper and the question from the AQA website if you want to have a go at doing the question first. It's completely freely available on their website. It's the 2018 higher chemistry paper and I'm looking at question number 8. If you want to look for further handouts or worksheets, you'll find them at my test shop. The address is below, and I'm also available to tutor over Zoom for chemistry and for physics. If you wish to skip through the video to the point that's more relevant to you, you'll find the chemistry part starts at about 1 minute, plotting starts about 4 minutes and 20, and the gradient is from 8 minutes and 40 onwards. Just to reiterate, the plotting and the gradient could easily be on a biology paper, a physics paper, or on a maths paper. So this is it, question 8 on the AQA Chemistry Higher paper from 2018. And as I was saying, it's freely downloadable. So download it and have a go at the question yourself first, and I'll go through how to answer it. So to start with, let's read through the question. A student investigated how temperature affects the rate of reaction between magnesium carbonate and dilute hydrochloric acid. The method used: heat hydrochloric acid to 30 degrees C in a conical flask. Add magnesium carbonate powder to the conical flask. Measure the loss of mass in the flask, so the flask must be on the scale, every 20 seconds for 140 seconds. Repeat for 50 degrees C. So maybe you've got to this question and you're really struggling. You don't know what it might make. Well, let's go through, first of all, the chemistry part. Then we'll go through the graph section and then we'll go through the gradient section. So first of all, explain why the contents loses mass. So what we've got here, we've got magnesium ions, Mg. Magnesium is a group 2, so it's 2 plus, with carbonate, CO3, 2 minus. And we've got hydrochloric acid, H is a plus, and Cl is group 7, so that's 1 minus. So we can work out the equation now of what's going to happen. We've got magnesium carbonate plus hydrochloric acid is going to make magnesium chloride, and there's going to have to be 2 of those because we've got 2 pluses there and only 1 minus over here, so that would leave us to MgCl2 plus. Well, what have we got left over? We've got hydrogen, we've got carbon, and we've got oxygen, so we get CO2 and we get H2O. Now, the equation is nothing to do with the question. If you knew about the equation, it would certainly help you answer the question, though. To balance it, we do need 2 of those. So where's the lost mass? The lost mass is here. It's the carbon dioxide. Why is it lost mass? Because that has escaped into the atmosphere. So a gas is produced, CO2, which is lost to the atmosphere. And that's the end of the first part of the question. Your 2 marks were for a gas is produced and goes into the atmosphere. The equation is just because that helps you answer the question. You may well have done this experiment yourselves. You may have collected the gas in a gas syringe and worked it from there. Okay, moving on to part 2. So we're now here at the second part of the question, and these are the results for hydrochloric acid at 30 degrees C. With the increase in temperature, we're actually looking at kinetic theory and collision theory, which will explain why there will be a difference in the 2 lines when you look at them later. If you don't know about those 2 things, then I would look those up. Our data here shows that we've got time in seconds and we got the loss of mass in grams. Taking a quick look down, loss of mass in grams only goes up to just below 1, and this is going up every 20 seconds. The x-axis is the time and the y-axis will be the loss of mass in grams. Unfortunately, they've put the data on a different page to the graph, so it does make it a little bit more awkward. But we can see from the graph here that we're going up in 25s. Here we're going up in 0.1 of a gram. I'll just delete those because what we need to look at is what each individual square is worth, and each individual square is worth 5 seconds on the x-axis, and on the y-axis it's worth 0.02 of a gram. When we know that, we can work out the numbers in between. Okay, so let's go through now plotting the data. And we've got 0 and 0. I like 0 and 0. It's an easy one to plot. Next one is 20 and 0.26. So 20 is there. 0.26 means we plot there. Remember, you go along before you go up. Next one is 40 and 0.48. So 40 is here, 2 below the 50, and 48 would be there. Next one is 60 and 0.67. 60 is 2 more than the 50, and 0.67 is halfway between two of the squares, which will give us a line of there. Next one, 80. 80 is 1 more square than 75. Hopefully you can see that there, 1 more square than the 75. And it's 0.82, which is 1 square above the 80. Next one is 100, and the last one I can plot easily, and 0.91 is half a square above the 90, 0.9 rather. The next one is 120, and for 120 it's 0.96, which is there. Lastly, 140, which is 2 off the 150, and the plot for that one is 99, 0.99, which is there, and we don't actually reach the 1 gram mark. Next we need to draw a line of best fit. Now your line of best fit from this data, obviously, I say obviously, maybe not, is not a straight line. I can't put my ruler on and get a straight line there, but what it does show is quite a lovely curve. So if I get rid of my ruler, and you can see there's a quite definite curve towards the 1 gram mark. So to draw this, you need to draw a curve. It's not easy on an iPad screen, like so. Okay, so that's your line of best fit. And it doesn't have to go through all the points. You'll notice I've missed a couple out, but as long as it's fairly close to them all, you'll get the marks for it. So we're now on to part 3 of the question, which is looking at figure number 7. And it shows the results for hydrochloric acid at 50 degrees C, following the method earlier. And what you can see is that it reaches 1 gram in 125 seconds, which is quicker than the previous one, which hadn't reached 1 gram even in 150 seconds or 140 seconds, which was the one that was recorded. And it had reached that more quickly. You want to know why? Then you need to look up kinetic theory. It's about the kinetic energy of the particles at 50 compared with the kinetic energy of the particles at 30 degrees C. Now on to this question. Determine the rate of reaction when the loss of mass is 0.95 grams. Show you're working on figure 8, 2 significant figures. And if we look at the bottom of the question, we can see that we need grams per second as our unit. to get grams per second, what we actually need is a gradient. And I'm going to just get the correct mark first on my graph for where I need the gradient. And it's at 0.95 grams. So it's just there where I need the gradient. I'll just move my ruler out of the way. Okay, and to get the gradient, I need to use the ruler to get a tangent to the line. Now you can see that bit there is a tangent at about 0.7 of a gram. That's the tangent at 0.8 of a gram. The tangent there at 0.9 of a gram, around there. And at 0.95 of a gram, it's, is it about there? I'm trying to get this. What I'm trying to get is the same amount of the black line both sides of my ruler. If I can get the, is that about the same? I think that's about the same amount of the black line either side of my ruler. So that should be about the gradient. All I do is I draw my ruler line wherever it goes through there. And that's now my gradient. I think that's a bit too low. So what I'm going to do is I'm going to remove that gradient and I'm going to draw another one, which is perhaps at the right point. That just looked a little bit too low to me. I can just get it back again. That looks... I think there is about the same amount on either side. So I'm going to go with that one instead. And you can see now, if you look closely, right at the center there, you can see I've just grazed the black line with my blue line, which is the tangent at 0.95. Okay, so that's my gradient. Now what I try to do is look for a point where my gradient line crosses some of the graph lines. And you'll see just here, it crosses the graph line. So that's an easy point for me to calculate. I can see that it's 0.8 and down at the bottom of the graph there at 25 seconds. I look a little bit further on, I'm looking for another one where it crosses, and I can see it crosses there. That would be 1.1 grams. So I'm going to use that point as well. So I'm just going to draw my line right the way down the paper. Let me just get this back and so I can see the bottom of the graph. And what I want to do is draw a line straight down using my ruler to there, and I'll draw another one down here so we know which points we're looking at. It doesn't really matter if it's not perfect this, because I can tell which one that one is. And across the top here, because what we're trying to do is we're trying to make one of those triangles that you use in maths to calculate the gradient. So now I have my lines correctly drawn on the graph. All I need to do now is work out the change in y and the change in x, and then I can calculate my gradient. So y goes from 0.8 to 1.1. So the change in y is 1.1 minus 0.8, which equals 0.3, and the units are grams. X, on the other hand, goes from 135 to 25, so it's 135 minus 25, which equals 110 seconds. Now I've got those two bits of information, I can put them into my calculator and calculate the gradient. Let me just show you how you do that. So the gradient is equal to the change in y divided by the change in x. The change in y was 0.3 grams. The change in x was 110 seconds. I'll plug those into my calculator now. So now we have to plug the numbers into the calculator, and it's 0.3 divided by 110 gives us an answer with 0.0027, and the 27 is recurring. So now I've got my answer back from my calculator. The answer is 0.002727, etc. We only need two significant figures though, so it's 0.0027, or I can write it as 2.7 times 10 to the minus 123 grams per second. Whichever you prefer, both are correct. Thank you, and that's the end of the question. Thanks for watching the video. I hope you liked it. Please don't forget to subscribe below if you want more help with your GCSE papers. There are also more resources available at my Times Education page. Have a look for the ray diagram and lenses handout. It's a very comprehensive one and not too much to pay. I'm available to tutor also over Zoom, and you can contact me via the comments below.